What if I told you the most powerful electrical network ever built on this planet wasn't invented by Tesla, wasn't funded by Edison, and didn't run on a single wire? It was alive. It stretched across entire continents. It carried energy, data, and chemical signals faster than the human mind could process. And before the 1800s, before we took axes to them, these megaforests were doing something so extraordinary, so terrifyingly efficient, that modern engineers still cannot replicate it. We didn't just cut down trees, we unplugged the Earth, the world before the silence. Before the industrial age, over 6 billion acres of ancient megaforest blanketed the Earth. These weren't just clusters of trees. They were singular, connected, breathing superstructures, each one older than most human civilizations. The Amazon, the Congo Basin, the boreal crown of Siberia, the Caledonian forest of Scotland, the Daintree, the primeval forests of Southeast Asia. These weren't separate forests. They were one system, and that system was electric. What science kept quiet? Here's where it gets shocking. Beneath every megaforest runs a network of mycorrhizal fungi, threads thinner than a human hair, that connect root to root, tree to tree, across thousands of miles. Scientists call it the Wood Wide Web, but that name doesn't do it justice. This network transmits electrochemical signals, actual, measurable electrical pulses. Trees send distress signals when attacked. They send nutrients to dying neighbors. They communicate in real time through an underground grid that functions almost identically to a biological internet. The voltage differences measured between tree roots and the surrounding soil, enough to power low-level electrical processes continuously. These forests were not like electrical grids. They were electrical grids. The megaforest as a living machine. Think about what an electrical grid actually does. It generates power, distributes it, regulates it, stores it, reroutes it when something fails. The megaforests did all of this, and more. Trees generate triboelectric charges through wind movement. They build up static potential through leaf friction. Lightning strikes a forest, and instead of a catastrophic surge, the network absorbs it, distributes the energy, and stabilizes. Ancient forests near coastal regions actually influenced local lightning patterns, acting as biological discharge towers. The catastrophe we don't talk about. Now here's the part that should keep you awake at night. Between 1600 and 1900 alone, humanity destroyed half of the Earth's megaforests. Not gradually, violently, rapidly. Continent by continent, we burned, cleared, and collapsed what took the Earth tens of millions of years to build. And when those forests fell, the grid went down. Ancient climate records show that after major deforestation events, regional temperatures spiked, rainfall collapsed, and soil lost its electromagnetic conductivity within decades. The land became electrically inert, dead. What we lost? Scientists today, studying bioelectricity in forests, are finding something deeply unsettling. The remnant megaforests that still survive, the old growth patches, the uncut sections, they still carry the signal. The network still hums, but it's fractured, interrupted, like a power grid, with half its substations blown out. And here's what haunts every researcher in this field. The grid is still there, barely. The trees are still trying. Even now, in the fragments of ancient forest that remain, the network pulses. The signals travel. The electricity flows. The megaforests aren't gone. They're wounded. And if we stop, just stop, cutting them down, the grid can rebuild itself. The Earth knows how. It did it before us. It can do it without us. But here's the real question. The question that should shake you to your core. If the megaforests were the greatest electrical grid ever built, and we destroyed it before we even understood what it was. What else have we already lost that we haven't even discovered yet?